All right, today we're going to talk about something that is absolutely critical for any Python developer. We're talking about managing your secret keys, your API keys, your passwords without ever exposing them in your code. Let's get right into it.
Okay, so picture this. You're building an awesome new app, right? And it needs to talk to some third-party service, maybe a weather API or a payment gateway. And that service gives you a secret API key. The question seems simple, but the answer is so important. Where do you actually put that key?
Now, if you're just starting out, or hey, even if you're in a hurry, your first instinct is probably to do exactly this. Just, create a variable, API key, and paste the string right in there. I mean, it's easy, it's fast, and it works. But trust me, this simple line of code, it's the villain of our story today. It's a mistake that can have some really serious consequences.
Yeah, this one little mistake can burn you in so many ways. For starters, if you push this code up to a public GitHub repo, bam, you've just handed your secret key to the entire internet. But even if you don't do that, it's still a nightmare to manage. Need to change the key? Well, now you have to go dig through the code and redeploy. And what if you want a different key for your local development versus the live production server? You're setting yourself up for a huge mess.
So what's the right way to do it? The professional solution, and really the main idea we're going to hammer home today, is this. You have to separate your configuration, your secrets, your settings, from your actual code. The code itself should be generic, and the configuration should be specific to the environment it's running in.
And the tool we use for this job is the humble environment variable. What is that? Well, think of it like a sticky note that you put on your computer's operating system. It's just a simple key-value pair like API key equals some secret value that lives completely outside of your Python program. But, and this is the magic part, your program can read that sticky note whenever it needs to.
And this approach gives us some huge benefits. The big one, of course, is security. Your secrets are never, ever in your source code. Then there's portability. The exact same code can run on your laptop, on a staging server, and in production. The only thing that changes is the sticky note, the environment variable, on each machine. And finally, it's super flexible. Need to update an API key? You just change the environment variable. No need to touch or redeploy your code at all. It's a game changer.
Okay, so how do we actually get these variables from the operating system into our Python code? Well, the most direct way is using Python's built-in OS module. It has this thing called os.environ that acts a lot like a dictionary. Let's take a look.
It's actually super straightforward. First, you just import OS. Then you can access os.environ exactly like you would a Python dictionary, using square brackets and the key you're looking for. So in this case, we're just asking for the username of whoever is logged in.
And just like that, it works. The operating system hands over the value, and our program prints it out. Easy, right? Seems like we've solved the whole problem. But there's a hidden trap here. A pretty big one, actually.
Yeah, this is the million-dollar question. What happens when your code is running on a brand new server and, whoops, you forgot to set the API key? Or what if you just make a simple typo in the variable name? What then?
Let's find out. We're going to try to access a key from os.environ that we know for a fact doesn't exist. Any guesses what's about to happen?
And boom, a big, ugly key error. Your entire application just came to a screeching halt. It crashed. This is a huge problem. You absolutely cannot have your production app go down just because one little configuration variable is missing. This way of doing things is just too brittle. It's way too unsafe for real-world code. Thankfully, the OS module has our back. It gives us a much safer alternative. So let's meet the real hero of our story, the os.getenv function. Honestly, this is the one you should be using pretty much all the time.
The syntax is really simple. It's a function, and it takes two arguments. The first is the key you're looking for, just like before. But the second one, that's an optional default value. This is what it will give you back if the key can't be found. And that default value is our secret weapon against those nasty key error crashes. So let's see it in action. Check this out. On the left, we ask for a key that we know doesn't exist, but instead of crashing, os.getenv just gracefully returns none, no crash. Your program can then check for none and handle it properly. And on the right, we ask for a port variable. If it's not set in the environment, no big deal. The function just gives us back our default value, in this case, 8,000. Your app just keeps on running with a perfectly sensible default. See how much better that is?
So let's just recap that crucial difference. If a variable is missing, using os.environ with the square brackets, it crashes.
key error. But os.getenv, it just safely returns none. os.environ has no way to provide a default value. os.getenv is built for it. So the bottom line is pretty clear, right? When you're reading configuration, os.getenv is absolutely the safer, more robust, and more flexible choice.
All right, so now you know the safe way to read variables. Let's cover a few more essential tips and best practices that are going to take your configuration skills to the next level.
Now, you're mostly going to be reading variables, but it's good to know that you can also set and delete them right from your script. To set one, you just treat os.environ like a dictionary and assign a value. And to get rid of one, you just use the del keyword. Simple as that. Okay, listen up, because this is probably the single most important gotcha you need to remember. Everything, and I mean everything, you get from an environment variable is a string. The operating system has no idea what an integer or a Boolean is. It just sees text, so everything it gives you is a string.
And what that means is that it is your job in your code to convert that string into the type you actually need. So if you get a port number, you have to wrap it in int to turn it into an integer. If you're checking a debug flag, you can't just say if debug. You have to explicitly check if it's equal to the string true. Forgetting to do this is such a common source of bugs, so please burn this into your brain.
And one last thing, you gotta understand scope. When your Python script sets or deletes an environment variable, that change only exists for that script while it's running. It's temporary. It does not permanently change the settings on your computer. The second your script ends, poof, any changes you made are gone. Okay, we've covered the theory, the big dangers to avoid, and the best practices. So now, let's put it all together and see what a really clean, professional, real-world configuration looks like.
This right here, this is a perfect example. We're building a configuration dictionary for a database. And look closely. Every single value is being loaded using os.getenv. We're providing sensible defaults for things like the host and port, which means a developer can just run the app right out of the box. And see that? We're correctly converting the port to an integer. This code is secure, it's flexible, and it's robust. This is exactly what you want your configuration to look like in a real app.
So there you have it. The best kept secret to managing your secrets in Python? Well, it isn't really a secret at all. It's just about using environment variables the right way with os.getenv. By understanding this, you've just taken a massive step forward in writing more secure, more professional Python code. So the only question left is, what are you going to configure next?